Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to discuss a very specific kind of dipole-dipole interaction. Now, if you need a refresher on dipole-dipole intermolecular forces, you can check out my video on it here. But let's see how some atoms are changing the game. As always, we will start with our definition. So the definition for hydrogen bonding is a strong dipole-dipole force that only occurs when you have a molecule that has a hydrogen that's bonded to either a fluorine, oxygen, or nitrogen atom. So it's very, very specific. Now let's go to some examples. We will compare water to hydrosulfuric acid. These two molecules on the onset look very similar, but if we look at their boiling points, they are quite different. You wouldn't just say that the boiling point for H2S is lower than water. It's crazy lower than water. So again, the question is, what is going on here? Well, let's look at our intermolecular forces. And to do that, we need Lewis structures for both of our molecules. So both water and H2S are bent. They both have polar bonds. So they both have the same overall dipole moment. The real difference here is that water, with its oxygen-hydrogen bonds, has hydrogen bonding as its dominant intermolecular force. H2S has a hydrogen-sulfur bond, but sulfur is not one of our special atoms up there. Therefore, the dominant intermolecular force for H2S is simply dipole-dipole. Since hydrogen bonding is a stronger intermolecular force than dipole-dipole, that means that the boiling point for water is going to be much higher than that for H2S. At the top of the screen, I have several water molecules here. And what I'm trying to show are the strong hydrogen bonding interactions here between these molecules. Now, if you look below at H2S, you will see that they also set up interactions. However, they're not setting up hydrogen bonding interactions. These are simply dipole-dipole interactions here. It is still an attractive force. However, again, it is just not as strong as the attractive forces with that hydrogen bonding. Something I want you to be careful about is relying simply on molecular formulas to determine intermolecular forces. Sometimes you need to look at the Lewis structure. Say, for example, I have two compounds with identical molecular formulas. One of these is called diethyl ether, the other is called butanol. Now, if you have not yet taken organic chemistry, which I assume most of you have not, you might not understand what these molecules actually look like. And so what you would see is hey, I have oxygen in both of these, plus I have some hydrogens. I must have hydrogen bonding going on here. However, if someone were to give you the boiling points of these molecules, you would realize that you need to reevaluate your assumptions. Why is butanol boiling at such a higher temperature than diethyl ether? Well, let's take a look at the 3D structure, which will show us how the atoms are bonded. So here is diethyl ether at the top. The oxygen is right in the center of the molecule. And notice it is not actually bonded to any of the hydrogens. It is bonded to these two carbons here. So diethyl ether is experiencing dipole-dipole forces. If we look below at butanol, here is our oxygen, and notice it is bonded to a hydrogen atom. So we have that very necessary oxygen-hydrogen bond. This means butanol's dominant intermolecular force is going to be hydrogen bonding. And it is that stronger intermolecular force that gives butanol that much higher boiling point. The last thing that I want you to be on the lookout for is not only the hydrogen bonding, but how many places a molecule can have hydrogen bonding. So we are going to compare methanol and water. Both of these molecules experience hydrogen bonding. Notice with methanol, however, there is only one oxygen-hydrogen bond. So hydrogen bonding occurs at one site. If you come down to water, we have two oxygen-hydrogen bonds. That means that hydrogen bonding can occur at two sites for each molecule. Again, if I compare boiling points, I will see that water's boiling point is much higher than methanol. This is simply because water has more sites where it can experience those strong attractive forces of the hydrogen bonding. So be aware not only of the hydrogen bonding itself, but also be aware of how many sites a molecule may have to experience hydrogen bonding. Again, getting the correct Lewis structure is so important in determining intermolecular forces. If you need any refresher or reviews on Lewis structures, I do have videos on that. Now, even though hydrogen bonding is still a dipole-dipole interaction, it's so strong that we have to give it its own special category. I hope you found this video helpful, and thanks so much for watching.